Bienvenidos a el 18º Congreso Latinoamericano de Dinámica de Sistemas. Es un placer para mí presentarles la plenaria número 9, titulada Best Practices in Model Construction and Construction Evaluation, presentada por Len. Bienvenido, Len.
Hello, everyone. Thank you for inviting me to present at the Latin America System Dynamics Conference in 2020. I wish we could all be together. I'd like to be able to see all of you that I know, my friends that I've met in the past, and I guess the virus isn't going to let us do that, so let's move on. This talk is about best practices in both constructing models and evaluating models. First, a few logistics. I used two small software examples, Vensim and Studio, because I own copies of both. The syntax in each is color-coded, so Vensim syntax is in red and Studio is in blue. In addition, all these slides should be available as PDF files in English, Spanish, and Portuguese. I did the Spanish and Portuguese conversion using the built-in Microsoft Translator, so there may be some mistakes. My motivation for doing this, I guess it goes back quite far, but I really started working on this in the year 2009, the first time that the international conference was held in Albuquerque, New Mexico, here in the USA. So these are my beliefs, that the methodology has benefited from lots of work in how we formulate models, how we model as a group, and how we test models. When we report on our work, we're typically reporting on models that we've built. But readers and reviewers don't know a lot about the process we used, not to develop the ideas in the model, but to actually do the construction. And I believe that that is a problem for model quality. So there's a missing stage in the process. I call it the model construction stage. I think it's appropriate and it's due diligence that we should improve the quality and therefore improve the usefulness of our models. So in conclusion, the field requires a measure or measures of the quality of the model construction process. In 2018, I reported on some work that I had been doing. I downloaded every model from the international conference from the years 2009 to 2017. I did not own a copy of Stella Architect at that time, so these are primarily Vensim and Studio models. I obviously couldn't understand them all. There were more than 300 of them. So I did some very simple objective looks at what I call construction quality. One objective measure is unit errors. Because of some of the issues with Vensim and the way that Vensim counts variables, I limited this graph to those models that had fewer than 1,000 variables. And you can see here the plots for each model point. This red line shows the condition when every single variable in the model has a unit error. And then this green line shows at the bottom all the models that had no unit errors. I'm not speaking about logic or formulation, but simply calculating the errors. And you can see the disbursement here between those two extremes. I did some other descriptive statistics, and I believe you can find that report in the conference 2018 proceedings. Before we go any further, what is it that I was measuring, and what is it might you be doing? What might you be creating? Will you be creating models, which are really abstractions from reality? Will you be creating an interface to that model so that you can have access to the model inputs and the model outputs? Will you be creating an application, or what some people call a flight simulator, which is the model plus a user interface? And then finally, will you be writing a report explaining the model and its results? We might like to measure your skill in doing that, in implementing the system dynamics methodology. And back in 2002, 18 years ago, the Society's Policy Council requested a report on what is mastery. And a person named Gordon Kubanek wrote this report. He identified 5 stages: a novice stage, which is basically a beginner; an advanced beginner, where you've actually built some models and you're starting to learn that you need rules, and sometimes you have to work outside of those rules. You also start to formulate guidelines for yourself on modeling. There's a competent stage. You've been practicing for several years. You have conscious, deliberate planning activities when you're modeling. You actually feel that you can call yourself competent. A practitioner stage, where you're doing this quite often. And then finally, an expert stage, where you're not following simple rules. You understand situations and you apply the right tool from your toolbox to those situations. There's nothing in these 5 statements about the model construction process or the quality of the model. We're talking about a measure of a person here. So let's get a little bit more terminology before I get deeper. Models and modules. A module is just a separate part of the model that you or your team, or you and your team, can say this part of a model can be separated from the rest of the model. Right? It doesn't send variables nor receive variables, not very many of them, from other modules. We'll see that a bit later. In fact, the module might be reusable in other projects or for other problems. A model then is just everything you wrote. All the code, all the variables required to represent your problem. An interface, access to the model for customers or clients, and for you for debugging. And then finally, what I call an application, some might call it a flight simulator, is taking that model and adding an interface to it so non-system dynamicists can listen to the story, make policy changes, actually understand the problem. So in such an application, right, which is the model plus interface, I claim you're going to find these kinds of variables, what are called exogenous variables, where you're getting data from external sources, from company reports, government reports, data out of the mental models of your clients, maybe even simple constants. The next category is endogenous variables. That's where your modeling skills come in. These are the internal calculations, the real system dynamics, the variables you create to understand the problem. In addition, since I'm using application as my example, you might create many variables just to enable your interface. You might aggregate values from a subscripted variable. You might disaggregate a value by some weighting scheme. You might establish control objects like switches, so you can try one policy versus another. You might create special variables for graphs and tables, etc. And then finally, you may have variables in your model that have nothing to do with the problem, but they're there for you to test that you're doing the work well. Software engineers might call this debugging. That's it. Every variable in a file, a software file, a Vensim, an AnyLogic, a Studio, a Stella Architect, should fit into one of these four categories. And then you decide how many of them you're going to expose to your users via your user interface. And that rectangle could get bigger or smaller. It doesn't have to be the same width for every category, but you're making a conscious decision. Okay? That's it for definitions about the models, the software models. Let's jump to quality. So that's what we're trying to do, and some of the components included in what we produce. So what's quality? What is it? Here's a dictionary definition. A state of being free from defects, deficiencies, and significant variations. Do we know quality when we see quality? And you might say the opposite. Do we know terrible work when we see terrible work? Why should we do this at all? Well, my experience, I've seen that I can reduce the costs of modeling. I can protect mine and my team and my organization's reputation. I can develop trust with clients. And that quality and that reputation and that trust can lead to further work. It also promotes the system dynamics methodology. Downloading a model from a system dynamics related website and finding that it's of excellent quality just helps the methodology and the modeler. So let's get more specific. With respect to system dynamics, or in that context, what are the metrics? What are the yardsticks or meter sticks? How do we measure? What do we count? What do we look for? Are there processes, right? Just like the process of following a cookbook. Do this first, do that second, do the next thing, etc. What are those processes? There isn't a agreed upon set right now for construction, not for formulation. And what are modelers doing when they're modeling? Are they in a hurry? Are they trying to finish this rapidly? Do they know what they're doing? Do they know the problem domain, etc.? And do we have any standards that we can compare to? As far as I know, there are no universally agreed upon set. There's a D memo from the MIT literature collection that speaks primarily about Vensim. That now is, let's see, it's 2020, 19 years old. And some of the software tool communities have informal sets of standards. So I'm going to put out some categories that quality measures might fit into. And as I do this, just think for yourselves, is this quality measure a binary quality? Can you look at the model, apply this measure, and say yes or no? Yes, it's quality, no, it's not. Or is this measure what's called a graded quality measure? And you could say, yes, people have followed this, but poorly, or they did a good job or an excellent job. Think about that. I'll go through these quickly and then actually do some examples of each of them. The use of color and naming. Units or dimensionality. How we do arrays and subscripts. What about modularity or partitioning a model? That's both an art and a science. How do we handle data? What about the coding style? How we write flow equations? And how do we lay out a diagram? And then finally, what I call pitfalls. Simple mistakes that most of us, if not all of us, make. How do we look for them? How do we avoid them? And again, remember, are these binary? Yes, indeed, this model followed this practice, or they followed this practice mostly, or perfectly, or poorly. Okay, let's take a look at color. I believe color is a personal or a team preference. There are no standard guidelines on color. Just make sure it has a purpose. Set up a scheme for yourself or your team, publish it, and stick with it. I've seen people do this. They've colored objects the same color as the screen background, which makes it look like the model's doing things that it cannot do because some variables are hidden. They're not on the diagram. And finally, don't color to make things look pretty. Beauty is in the eye of the beholder. And some people might look at your model and say, that's not pretty at all. Here's an example. This was based on a 1971 homework problem at MIT about migration and back and forth across the US-Mexico border. The model was originally built in Dynamo and it was converted to PowerSim Studio. I know I presented it at one of the conferences. But in order to make our clients comfortable with looking at a stock and flow diagram, we decided to color the elements. So stocks or flows or auxiliaries or constants that dealt primarily with the USA, they were colored red. Likewise, Mexico variables were green. Things that happened on the border were gray. Exogenous inputs, data from the outside, yellow. Indicators or metrics, black. We put this grid over the variables that had embedded table functions. And then we colored part of our model diagram, this violet color, to grab people's attention and say this is a variable where you can make a policy change. Okay, naming. Make your names clear, unambiguous. We are not modeling in Dynamo anymore, as far as I know. Dynamo characters were names were 4 to 6 characters long. You had to do a lot of memorization. Don't use uncommon abbreviations. Once had a job to evaluate someone else's work. We found this concept fuel type. I think it was spelled more than 6 different ways. We weren't sure that the modeler meant the same thing every time. Be clear. Use acronyms sparsely and use them if they're accepted in the field, the problem domain. For example, people working in energy markets might use KWH. Small k, large W because that represents a person's name, James Watt, and H for hours. So you're free to use that instead of writing out kilowatt hours because your clients are familiar with it. I tend to resist using digits unless my client specifically says, hey, we call that power plant 2 with a digit 2. This one for sure resists using special characters. This can make the equations very difficult to read, and some of these characters aren't allowed in some of the software packages. At least they're not allowed as variable names. So the D memo from 2001 says this, and it was written for Vensim models. Constants should be in uppercase. For example, initial population as a constant. All auxiliaries, including flow rates, should all be in lowercase. Population growth rate, for example. Stocks should have the first letter of major words in uppercase letters. Corn stock. And these hold true unless, of course, they would violate one of these other rules that typically come from your client. So here are some examples. I know there's probably a few Vensim people out there. Now there is a great Vensim model, right? I'm sure you all understand exactly what's going on there. And I don't want to forget the Stella folks. I think this one is from a textbook. I have no idea what that model is doing. And then I did this on purpose. This is for one of my courses that I teach. This one's in PowerSim Studio. And I think you all can imagine, all of you who know how to build a model can imagine what the flows are, what the stocks are, what the constants are. Studio just uses different icons than the other two packages. So it has similarities to Vensim and similarities, but that's not the point. The point here is in this one, I tried to follow those rules. Keep going. This next one you're going to see came from a model submitted to one of the international system dynamics conferences. How about that for naming and layout? I'm sure everyone here understands it, and I really hope that this model doesn't belong to any of you watching this video. It was in Vensim, you can probably tell. So I just opened the model settings here to see if the modeler had told me anything about what the problem was, who they were. It's probably good that they didn't tell me who they were, etc. So you might be appalled by something like this. You might even laugh a bit. But you stick with system dynamics in the society, someday you too will be a thread chair and an evaluator, and you're going to have to evaluate models like this. But I take that back. Because you're listening to this, and others have, we will never have to evaluate models like this again, I hope. So there's a very famous singer from my hometown named Aretha Franklin, and she has a great song called Think. And that's basically what I'm asking all of you to do is, please think before you produce something like this. Okay, let's go to the next topic. Units or dimensionality or dimensional consistency. Units are a part of every good software tool. If it's not in the tool, it's not a good tool. And I will argue with anyone, no matter who they are, that no model is so small that it does not require units. Every model requires units. For me, as an evaluator, it's very easy to fail a model. The quickest way to fail a model is to run a units check. If there are any errors, reject. You have no confidence in the model after that. Use standard international units as much as possible, and document when you do unit conversions. Here in the United States, we still use feet and foot. So if you're going to use a unit of measure like that, maybe have a reference somewhere to a standard international unit, which in this case is meters. One thing we've done, especially with teams, we open our software. My old group usually worked in water resources and energy. We would open our modeling tool and fill it with units, no variables, no stocks, no flows, no auxiliaries, no constants, just units, and save that. And then every time we started on a new problem, we'd open that model, rename it for the current problem, and save ourselves a lot of time. Next topic, arrays. They're called ranges in PowerSim Studio and subscripts in VenSim. Never start building a model with arrays. Get your dynamics down. So let's say you're doing a business model and you're managing a product. Maybe it's for sale in 5 different regions at 6 different locations in each region. That's important to your problem. So you've got 30 elements in your array. Don't start your model that way. Start it assuming one region and one store. Once you get those dynamics working, then go to the detail. You could, on the other hand, not use arrays, ranges, or subscripts and just duplicate code. Right? It starts to get a bit difficult to handle as the number of copies increase. I used to have a rule that if a common behavior has to be subscripted into 3 or more subscripts, or 3 or more copies, then I would start using subscripts. If you don't use subscripts, you take up more screen space, makes it harder to understand. If you have any changes to logic, you have to remember to find all the instances of the duplicated logic. Or you could use subscripts or ranges. And that's basically the same thing that I just said. Let's take a look at another idea, complexity. This is where we talk about modules and two units of measure having to do with modules. Just like for each of us, we could measure our height, we could measure our eye color. Well, for modules, we could measure what are called coupling and cohesion. And these ideas came from the software engineering field. This is a graphic that I made. We were hired to evaluate some other modelers' work. In their work, I believe there are about 42 different modules. That's what the blue circles represent. The red lines are saying that this module communicates with that other module at the other end of the line. And the numbers in black are showing me how many variables, not values, but how many variables are being passed back and forth between any 2 modules. This model total had 2,918 variables, and it did a lot of ranges or subscripts to the point where there were more than 8 million pieces of data in this model. And 45 different units were assigned. Here's a much simpler model from the literature. I think there are 12 modules here. This is much easier to read. Same idea. The circles represent modules, the lines are communication between the modules, and the numbers are how many variables get passed. And notice here that, just as an example, between Section 6 deterrence and Section 7 enforcement, there are no data being passed between those two, for example, over on this side too, between population and legitimacy. The goal here is to, if possible, minimize the number of lines and minimize the number of variables that get passed from module to module. This one only had 168 variables. It used subscripts. It had 556 elements and 15 kinds of units. Okay? So, a little more detail. Cohesion means how tight, how can this module, or can this module be reused, basically? Is it dealing with one and only one thing? And that'd be great, because maybe I can reuse it on another project. I have a demographics module that I've used so many times in so many different projects for both people and things. Paige Jones has a whole textbook. The reference is down here. System dynamicists don't have to worry about all these, and we rarely have to worry about sequential or temporal cohesion. We're mainly concerned with functional cohesion. So we want our modules to be tightly cohesive. Plug and play. Coupling, on the other hand, has to do with communication. How much does one module need to receive from another one in order to function? How much does it have to pass to other modules for them to function? Ideally, we want that communication to be as low as possible. I shouldn't have to worry about what's going on in other modules. So basically, send enough, but no more. So here we strive for loose coupling. Tight cohesion, loose coupling. If our modules are tightly cohesive or strongly cohesive, it automatically leads to loose coupling. And the reverse. If we strive for loose coupling, we will end up with tight or strongly cohesive modules. Just pointed out here a couple of them. This one was sending 18 values between population and social control effects. And here between punishment and legitimacy, it's sending 2 variables. When you're building a model, you might have these kinds of modules that don't have anything to do with the problem. You might create a module. Well, how do you do that physically? In Studio, it's a tab. In Vensim, it's a view. I forget the name in Stella. Maybe it's a component. Make one. Put your notes in there. Make another one. Maybe have a list of best practices that you can see as a reminder. Make another one for things that don't really work, or things that you can throw away, or things that you want to save to be used at some future date, but they're not required to make this problem understood. And have a parking lot or a debugging module to move the items over that literally don't work at the end of the day. One of the students at summer school this past summer said he has a 3-minute rule. Every 3 minutes, the model should be running. We used to have an overnight rule that at the end of the day, the model, everything in the model is running. It also means it has units and all that other stuff. The things that don't work, they get moved to a debugging module. Data. Really good practice to try to keep the data in the format in which it arrives. If it's an Excel spreadsheet that you get from a government report, keep it in that format. Don't change rows, don't change columns, don't do any manipulation. Do all that inside your model. You tend to find that as your models get bigger, they become data focal points. It's usually true that no one has ever gathered all that different kind of data together in one place, right? Because they're not system dynamicists like you are. So watch out, be careful. Be careful using spreadsheets. Try not to do much of the calculation in the spreadsheet. Use it for bringing in data or exporting results. If you use a relational database, and for those of you who know what that means, make sure to normalize your data model. If you're uncertain about that, try to find, a database designer who can help you do that. Document, document, document. Another tip, store your time series vertically. Spreadsheets usually take more rows than they take columns. Another problem with data, this is particular inside your model. Don't use embedded constants. I've seen models where I've read a flow equation, and maybe I've read something like population times population growth rate times the number 6. What is the number 6? Some software doesn't require a unit on that number 6. Some do. But that's what I call an embedded constant. Watch out for those. Get rid of them. Make them separate variables. And that includes initializing stocks. That's one of my quality rules. If a stock has an initial value that is not 0 persons, 0 kilowatt hours, for example, then you must create a constant which holds the initial value of that stock. Okay, coding style. Leave no blank lines at the top. You can read this, use indentation. Don't leave unused code with comments in a definition. Move it, I guess, in Vensim down to the bottom in the documentation. In Studio, there's a documentation tab. Likewise in Stella. Okay, layout. That's how does the model picture look? Is it clean? Do you use what are called shadow, ghost, or snapshots liberally so you don't have lots of crossing lines? And don't change the relative symbol sizes. If you have to make a symbol bigger, do that for emphasis, not for fun. This is much like color. So here's an example. This one's PowerSim Studio. It's looping through a range, through an array here. So this is how the actual code was written. Which would you prefer, the top or the bottom? The software accepts both of these. I find the bottom one much, much easier to read. Okay. Here's an example from Vensim, again from an actual model. That's the code that was embedded in, I believe, a flow rate. Or, how about this? You have an initial rate and you're adding the result of a ramp, which is basically a linear progression added each year onto that initial value based on some kind of a slope. Okay, just examples. Here's an example of layout coming up. It's also got some other interesting features in it. This person did not use subscripts. They have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 stocks. That could be done with one stock that's subscripted. I'm not really happy with the naming here. This also could have been subscripted. Looks like a whole bunch of constants. And there's another problem here that's common in lots of software, trying to distinguish an O from a 0. Of course, now you've got all these lines crossing because I don't see any, what does Svensson call them? Oh, there's just time as a shadow variable. So remember what I said very early, when you look at something, can you tell that it's good quality? When you look at something, can you tell that it's poor quality? Let me move forward. Here's some more examples of layout and naming. I believe this came from a textbook. Not really happy with variable names called P, I, and CVP, and C, and YX, and C, and W, etc. Here's another one. This is a Vensim example again. I got a feeling this might be work in process. Sales, that might be inventory. Not really sure. Oh, actually, this isn't Vensim. This is a PowerSim Studio model. Just I can tell from the objects and this little icon that there's a delay function hiding in there somewhere. Here's an error message that this isn't probably defined. But, you know, if my students turned this in, this would be rejected. Coding pitfalls, just a few. This one gets people quite often. You've got a variable, it's in a denominator, and you don't know for sure if it could ever be 0. And when it is 0, the software crashes because you can't really divide things by 0. You can solve that by using some of the so-called div functions. That's a common one. Another one, equation complexity. George Richardson says if an auxiliary has more than 3 inputs, it's time to create a new auxiliary. He calls that Richardson's rule. I violated that many times, but I try to make it clear in the model what I'm doing. And then this is one that gets me, especially when students return a homework assignment. You know, it'll be assignment 1 and they'll turn it in and it'll say assignment 1.sip. Well, what's that assignment about? Who built the model? Here's a silly example. This model has to do with fly swatter sales. Its date is 2010, the 10th month, the 22nd day. It was built with Studio 8, Feature Pack 2, Service Release 5, and the .zip, that's the extension for PowerSim Studio models. If it was Vensim, right, it would be MDL, and depending on what you do with Stella, it could be an XML file. Okay, so the following slides are checklists, lots of checklists. You might want to print these and remember again, they're translated into Spanish and Portuguese, hopefully correctly. You might want to clean them up. But this is what you think about before you start building the model. Have you thought about units? Have you thought about the time unit? Is it month, day, year, second, etc.? What's your DT, your time step? When is the model going to start running? When's it going to stop? Do you have a naming convention? Things we've talked about. That's before. Okay. During construction, you keep checking this yourself. Does every variable have a unit? Are stocks initialized with a constant if their value isn't 0, etc., etc.? Now, what if you're evaluating other person's work? Do you know what the measures of quality? You open it up, what's the first thing you're going to do? Is it going to be to see if the model runs? Then, if it runs, are you going to check whether it has unit and errors or not? Are you going to look for if, then, else in the equations and make sure they're not used much? And what else will you check for? And basically, if you don't know the problem area, right, the problem area which might be international migration, and you're an engineer and you don't know anything about it, you might not be able to comment on the logic. So are there any objective measures of quality? So think about this. Somebody gives you a model. Can you actually point out the quality problems in it? There may be none. And secondly, can you fix them? That's much, much harder because, again, you might not know the problem domain. More things to do when evaluating, and again, you have these checklists. I read a paper that some folks did about model testing. They tried to take some of the common tests that are pointed out, I believe, in a paper by Jay Forster and Peter Senge, and they used a clock to measure how much time, and I believe it took much more time to test the model than to build it. So these things can take quite a long time. Here are some subjective measures where you're taking a graded approach. What if the model's got 100 variables and 98 of them have really good names and 2 don't? Does that model fail in quality, or is this a graded approach? Okay. Then I also would like to recommend this text. I don't know if Spanish and Portuguese translations exist. It's called the Electronic Oracle. There's a fantastic section near the back of the book on if you have to write a report about the model, about the modeling. I've got 3 screens here of items that you might want to include. Very, very well done. Okay, so after you leave the conference or tonight at home, whenever you get an opportunity, try to build this model. Very simple. And then try to go back and see if you've followed the practices that I'm trying to recommend you use here in this presentation. Okay? Try to use best practices. Remember, every tool has different syntax, but system dynamics conceptually, its semantics, are not different. So you're going to be using system dynamics concepts with the syntax of the software that you use. Give that a try. Here's another thing you might try to get better at what you do. Go to the System Dynamics Society website, go to conferences, past conferences, pick a year of your choice. I think you'd have to pick 2017 or earlier. Find a paper that interests you that has the word supporting in blue, and then see if there's a model attached. There may be, it might not be in the software that you use, so you have to skip that and find another paper. And then once you find one that's in a software that you use, open it up and start trying to apply some of these techniques. Try to evaluate what other people have done. I truly believe that we don't have to make all the mistakes ourselves, that wise persons can learn from the experience of others. Here's another exercise for you. Make some lists. What do you think? Maybe you don't agree with me. Are there other things that you think about for model quality? Are there pitfalls that you know about that you'd like to warn us about and the community about? And do you have a best practices list? If you need or want to contact me, I'm sure you can find out how. Just send them along. I'm trying to remember when all of this actually started, where I used to work. It might have been as far back as the early 2000s, so close to 19, 20 years ago, when a hydrologist friend of mine who was doing system dynamics and I sat down and we started worrying about the work that our team was doing. And we started talking about things like this. And we really didn't put anything on paper until I wrote a little manual. I believe it was in 2011, maybe earlier, I can't remember. But contact me if you'd like that. It only speaks to PowerSim Studio right now, but it has applicability to really any system dynamics software. And finally, thank you. Obrigado. Gracias. I really believe this is important. I think the first time I mentioned it at a conference was the PhD colloquium in 2015. Some of you may have been there, I don't know. But this is really important to me, and as Jay Forrester said when he was more than 90 years old, Jay, what is it that you do? And Jay's response was, I'm a student of system dynamics. And I'd like to steal that idea and say, I'm a student of system dynamics model construction. Thank you very much again. Goodbye.
Muchas gracias, Len, por este plenario tan interesante. Les recuerdo que este congreso está presentado por la Asociación Colombiana Dinámica de Sistemas, el capítulo brasilero y el capítulo latinoamericano. Sigan disfrutando de nuestra programación.
Hombre, Silvio, estás absorto mirando tu calle, que te tramas.
¿Qué tal, Luis? Pues mira, me alegro de verte porque quiero decirte y a todos ustedes que se va a celebrar del 26 al 30 de octubre el 18º Congreso Latinoamericano de Dinámica de Sistemas, en el cual tengo el honor de pronunciar la sesión inaugural, y aprovecho para dar las gracias a los organizadores de este honor que me hacen y también invitarles a que participen virtualmente en esta importante reunión.